Hi everyone, welcome back to our channel. This video is a continuation from the last video, Sketching Polynomials Part 2. So in this video we are going to learn to draw more complex polynomial functions. For example, here you see an equation y equal kx n. This can take many values. For example, let's say k is 2. So you'll have y equal 2x to the power 1, y equal like 2x to the power cube. You have seen this one in the last video. What about y equal 2x to the power 5? So what is common across all these three is the power is an odd number, right? Similarly, we can have y equal 2x squared, 2x to the power 4, 2x to the power 6, and 2x to the power 8. And the power of x is even number. Right? Similarly, what we can do is we can have an odd number for the coefficient. So here all the coefficients are positive. Let's see if it's like, for example, y equal minus 3x to the power 1, minus 3x to the power cube, minus 3x to the power 5. For the even powers, let's say minus 5x to the power 2, minus 5x to the power 6, minus 5x to the power. Alright, so in this video we are going to learn how to plot these graphs. Let's see how we can plot y equal 2x to the power 1 or 2x to the power cube or 2x to the power 5 and so on. So we have seen how to plot 2x cube, right? If you remember that graph y x, the graph is something like this, right? So this is y equal 2x cube, right? But if you plot any of this graph, they will also take a similar structure, right? It will be similar. For example, if you draw this properly, this is probably 2x to the power 5. All of them will take similar structure. What about y equal minus 2 to the power x to the power 1, 2 to the power x to the power minus 2 to the power x cube, minus 2 to the power x to the power 5, and so on. If it is minus coefficients, then this would be like this. It will be flipped, right? So these are y equal minus 2 x minus 3, and even if we draw minus 2 to the x to the power 5, say, as long as these are odd numbers, the powers are odd numbers, they will take a shape something similar to this one. Let's look at the even numbers. So for example, y equal 3x squared or 4x to the power 4 or 5x to the power 6 and so on. If you take a even powers, that will take shapes like this, right? Same as like quadratic. As long as this is even, it will take a convex type of graph. What about the coefficient of x is minus? For example, y is equal to minus 3x squared, minus 4x to the power 4, minus 7x to the power 6, right? So if the coefficients are negative, then this will become a concave, right? So it will have a shape like that, right? I hope this makes sense, right? So as long as you remember the graph for quadratics and cubics from the previous video, you could able to draw higher order polynomials like x to the power 2, x to the power 4, x to the power 6, and so on. As long as you just need to check the power of x as well as the coefficient of x. If the coefficients are negative, then you will flip the graph. If the power of x is even, then the graph will stay on the one side. But if the power is odd, as you have seen in the previous one, it will flip. So thank you so much for watching this video, and we will do one more video shortly. Bye bye.